All right, today we're cracking open the blueprint for something truly wild. A plan to build an entire self-sufficient, high-tech city from scratch, basically in a box, in one of the most remote places you can imagine.
I mean, think about it. How do you build a modern city from the ground up? How do you get reliable power, high-speed internet, a real economy, to a place that has no national grid, no paved roads, basically no existing industry? And here's the kicker. How do you do it all sustainably? Well, it turns out one project has a pretty radical answer. You have to go deep into the Karamoja region of northern Uganda to find it. It's called Project Umoja Kaabong. And they're not just, planning to build a town. They're deploying a completely self-contained, self-powered, high-tech ecosystem. So let's pull back the curtain and really unpack this incredible blueprint. So what is the grand vision here? Well, first off, it's not just about building a single factory. The idea is to create an entire economic ecosystem, a profitable, completely eco-friendly industrial park in a place that has for a long time been left off the development map. And the scale? I mean, it is just immense. We're talking about 7,000 acres. That's bigger than many towns, all dedicated to this brand new model for development.
But this isn't just about the sheer size of the land. The goals here are way bigger. We're talking about creating thousands of jobs for the local community, generating its own reliable power, 100% off-grid, and designing a zero-waste system where every single output becomes a useful input somewhere else. And the ultimate goal? To create a template, a model that could be picked up and copied all across the continent. Okay, so the first, and let's be honest, the biggest hurdle you have to clear is power. Without reliable, affordable energy, nothing else happens. So how in the world do you generate enough electricity for an entire industrial park in the middle of nowhere? Now, the answer they came up with is not what you'd expect. It's not solar, it's not wind, at least not as the main source. The whole project is essentially powered by one single amazing plant, industrial hemp. And not for the reasons you might think, but for its biomass, the huge volume of stalks and woody core it produces. And this is where the genius of the system really starts to click. It's a perfect, self-sustaining circle. Okay, follow me on this. It starts with growing hemp on a massive scale. The valuable parts, like the fiber and the oil, they get processed for export. But all the leftover waste, and we're talking 210 tons of it every single day, that becomes the fuel for the power plant. This generates more than enough electricity for the entire park. And get this, a key byproduct called biochar goes right back into the fields as a natural fertilizer. It is a perfect closed loop. Now, the tech that makes this whole thing possible is just incredible. It's called plasma gasification, so forget everything you know about old-school incinerators. We are talking about temperatures hotter than the surface of the sun. It basically vaporizes the waste into a clean fuel gas. And that extreme heat is the secret sauce. It completely obliterates the toxic tars and pollutants that make other waste-to-energy systems so dirty and just a nightmare to maintain. But okay. Here's the multi-million-dollar catch. This technology is usually insanely expensive. A plant of this size could cost anywhere from $27 to over $80 million. So the project's entire success really hangs on this one very bold claim, that they can build it for just $10 million, using a new, more efficient modular design. A huge gamble. So, you've got the agricultural muscle and the energy backbone, but this thing isn't just a farm and a power plant. No. It's a smart park, and it's all run by a seriously sophisticated digital nervous system. The brain of the whole operation is an AI software platform called Rios. What it does is create a digital twin, a living, breathing virtual model of the entire 7,000-acre park. It's constantly monitoring everything from the moisture in the soil to the growth of the crops to energy use, even global market prices. And it's running simulations nonstop to make the whole system as efficient as digitally possible. And to run an AI that powerful, you need some serious horsepower. This is not just a few servers tucked away in a back room. We're talking about a massive on-site data center with the kind of computing power you'd normally find in a top-tier AI research lab. It's just a level of digital muscle you would never expect to see in a rural development project. And the whole philosophy behind this digital layer is pretty different too. It's built on a concept called DPIN, which stands for Decentralized Physical Infrastructure. The easiest way to think about it is like a community-owned internet, but for physical stuff like power grids and data networks. Instead of one big company owning and controlling everything, the network is designed to be more resilient, more equitable, and operated by the people who actually use it.
Okay, so the vision is incredible. The technology is absolutely cutting edge. But how do you actually build it? How do you go from an empty field in the middle of nowhere to a fully functioning smart city?
Well, the plan is a really smart, phased rollout over 5 years. They don't just show up and try to build the giant 10-megawatt plant on day one. No, it starts small. Year one is about securing the site with solar power. Then comes a smaller 1-megawatt bridge plant to power the initial construction. The full park microgrid doesn't even go live until year three, and it's only in year five that the main plant finally comes online for full commercial operation.
So, how do they solve that classic chicken and egg problem, needing infrastructure to build infrastructure? They start by just dropping a single self-contained shipping container on the site. This thing is solar-powered, it has its own satellite internet hookup, and it provides all the basic power and connectivity they need to get construction started immediately. It is, quite literally, infrastructure in a box. And this whole approach allows them to make this incredibly powerful statement, which is captured perfectly in their strategic plan. They say, "We are not just planning, we have landed." Think about that. They're not just asking for money for some far-off idea. They're already on the ground, their systems are active, and they're collecting data from day one. Okay, so let's tie this all together. How does this incredibly complex blueprint actually become a self-sustaining reality? What does that final economic engine actually look like when it's all up and running? The economic engine is actually really clever. It's designed with two core revenue streams. Locally, it acts like a utility company, selling that super reliable off-grid power and internet to all the businesses that set up shop inside the industrial park. But then, on the global side, it can sell any spare capacity from that massive data center to clients anywhere in the world who need high-performance computing for things like AI, research, or 3D rendering. And that computing power creates its own local opportunities too. So for example, the Karamoja region is known to be rich in minerals, but exploration is really tough. Well, the on-site supercomputer can chew through complex geological survey data and create these super detailed 3D maps of what's hiding underground. This alone could attract mining and exploration companies, creating yet another high-value local industry that was just impossible before. The initial $30 million investment is mapped out super clearly, and you can see that the vast majority, fully 2/3 of the entire budget, is dedicated to the hard assets, the plasma power plant, and the industrial processing facilities. This tells you it's a project focused on building real, productive infrastructure from the ground up. Which, of course, leaves us with the big final question. The blueprint is undeniably brilliant, a self-contained, self-funding, zero-waste ecosystem. But its success depends on weaving together cutting-edge AI, groundbreaking energy tech, and really complex logistics, all in a very challenging environment. So, is this a truly scalable model for the future of development? Or is it a beautiful but fragile high-tech dream? The answer, I think, is going to be written not on paper, but in the soil of Kaabong itself.